Alright, let's continue the strict triangular form to convert a more complicated n by n system in a much simple and easy equivalent system. So that is the purpose of the strict triangular form. Now let's write the n by n system first. Here, those are the first two equations. Okay, here are the first two equations. Then let's continue with the nth equation. That is ak1 x1 plus ak2 x2, and then we can write in this way. Okay, we can write in this way. ak minus 1. Sorry, akk minus 1. Okay, akk minus 1. Let me just write again. Okay, a2 kx2 and akn xn equals bk. That is the case equation. And the last one will be an1 because we have n equations, plus an2 x2 plus ann xn equals bn, right? So here, all the aij are called coefficient. Okay, all the aij's are called the coefficient. As I said, bi's are called the right side constant. Okay, right side constant. Now, what does this one mean? What does this one mean? The first, for the case equation, okay, for the case equation, for example, this one, the case equation, the first k minus 1 variables are all zero, the coefficient for the first k minus 1. So we have x1, x2. Here we can extend it in this way, plus a k minus 1, right? A k minus 1, the variable will be xk minus 1, and then plus a k xk, and then plus a k plus 1 x k plus 1, right? If we check those terms for the case equation, so what does this mean? That means the coefficient for the first k minus 1 variable becomes 0. So ak1 is 0, ak2 is 0, k minus 1 is also 0, but this is non-zero. The coefficient for xk is non-zero, and we don't care about those after xk. It might be 0 or not. Then that is the case equation. My k can starting from the first until n. So for example, when k equals 2, that means the second equation. That means the first one, k minus 1, that is 1, right? K minus 1, that is 1. So that means the first coefficient is 0. And for x2, k equals 2, x2 is non-zero, right? The coefficient for x2 is non-zero. So for the first one, how about for the first one? For the first one, no coefficient becomes 0, right? So you will notice that. How about when k equals n? The last equation. That means the first k n minus 1 coefficient are all zeros, right? 0, 0, and here we have an n minus 1 plus xn minus 1. This one is also 0. We only have the ann, the coefficient for xn is non-zero. So how it looks like if those coefficients are all 0? This is the first one, right? So for the second one, A21 is 0. For the third one, A31, A32 are 0. And until the last one, only ANN is non-zero. The first n minus 1 are all 0. So that is formed the right side. The left side is forms like a triangular form. That is we call the strict triangular form. Okay, because the other terms all becomes 0 since the k minus 1, the coefficient for the first k minus 1 variables are all zeros. That is what we define the strict triangular form. Okay, strict triangular form for the n by n systems. And try to understand the definition in this way. Okay, we are going to have more definitions in future like this one. Okay, it's not the definition or series like the calculus. Okay, it's in this description. So that is strict triangular form for n by n system. If we check the specific one, that is much more clear. Okay, that is much more clear. For example, example one. This is strict triangular form. Everyone is clear? Of course, this is 3 by 3 system, 3 equations and 3 variables, right? It's 3 by 3 system. No problem, right? Why it's a strict triangular form? For the first equation, we have all those. For the second equation, the first coefficient is 0, right? For the third equation, the first two coefficients are 0. Make sense? And I think all of us would like this strict triangular form because it's very easy to solve that, right? If you check the last equation, we only have the variable x3, right? So we can solve this strict triangular form in an easy way. We check the last equation, which only involves one variable. So x3 will be 4 over 2, which is 2, right? Then we go back to the second equation. That will be x2 minus x3. x3 is 2 equals 2. What is my x2? My x2 is 4, right? My x2 is 4. So x2 minus 2 equals 2. Of course, x2 is 4. And then we can go back to the first equation. 3x1 plus 2 times x2 plus x3 equals 1, right? Then x1 equals 1 minus 10, which is 3x1 equals this one. So x1 equals minus 9 over 3, which is minus 3. So the solution for this 3 by 3 system always go to the order x1, x2, x3 in this way, okay? In this way. So x1 is minus 3, x2 is 4, x3 is 2, right? Of course, the solution will satisfy those 3 equations simultaneously, right? It's easy. So why we need the strict triangular form? It's easy to solve the system, right? And it's a square one, n by n, right? N by n. We have 3 equations with 3 unknowns. So everyone is clear how to solve example 1? I go through very quick because it's pretty easy. Okay, it's pretty easy. Now let's check one more. Okay, let's check one more. So what is the method we are doing here? That is called back substitution. Okay, back substitution to the last equation, third one, and go back to the second one, then go back to the first one. So any n by n strictly triangular system can be solved in the same manner as the last example. First, the nth equation is solved for the value, for the unknowns xn, right? We solve the xn first. And then this xn is used for the n minus 1st equation to solve xn minus 1. And then both values xn, both solutions xn and xn minus 1 are used for the previous, right? Go back to one equations n minus 2, and then until we solve the first equation to get x1, then we will refer this method. Okay, we will refer this method of solving a strictly triangular system as a back substitution. Okay, so this method is called back substitution. It's pretty easy, right? Pretty easy to solve that. Let's check one more example. Okay, one more example. Solve this 4x4 system, right? 4x4 system. Using the back substitution. Okay, of course this is still a triangular form, right? So is everyone clear? That's why we called it triangular form. Okay, triangular form, because it's formed in this format, right? This format. So we call the triangular form. Okay, triangular form, because the A21, this position is A21, A31, A32, A41, A42, A43. Those coefficients are all zeros, right? So that gives a strict triangular form. And we are going to use the back substitution to solve this 4x4 system. It's a 4x4 system with 4 equations and 4 variables, right? It's a 4x4 system. Now equation 4, the last equation we can solve, x4 is 4 over 4, which is 1, right? Which is 1. And then we go back to the third equation. Third equation is 4x3 plus 3 times x4. x4 is 1 equals to 3. So what is x3? x3 equals 0. And then number 2, x3, x2 minus 2 times x3 is 0 plus 3x4 is 1 equals 2, right? So my x2 will be 2 minus 3, which is minus 1. And then use the value, use the solution x4, x3, x2, go back to the first equation, 2x1 minus x2, x2 is minus 1, plus 3x3 is 0, plus minus 2x4, x4 is 1, equals 1, right? Now let's solve x1, right? x1. So here is minus 1, right? So 2x1 equals 2, right? Equals 2. Then x1 is 1. So the solutions for this 4x4 system using the back substitution, x1, x2, x3, x4. And you can check, actually, after you solve you get the solutions, you can check whether it satisfies all the equations simultaneously, right? If your solution couldn't satisfy all those linear equations, that means your solution is wrong, right? So that is pretty easy to apply the back substitution to the strict triangular form. It might be a little difficult to understand the definition of strict triangular form, but it's much more clear to look at the specific example to understand why we call the triangular form, right? Triangular form. So we will stop here today, and I will send you a quiz. Okay, I will send you a quiz. We will solve those later. Okay, we will solve those later. So this is also a 4x4 system. 4x4 system, and you need to use the back substitution to solve all those x1, x2, x3, x4 values. It's not multiple choice question. It's fill in a blank. So you should fill in a blank for each values. Okay, for all the 4 values. I will set up 5 minutes to finish this quiz.